Nobody likes using the lookup tables in the back of your book. At best, you have to flip through a bunch of pages or scroll through a bunch of electronic pages to find the data, and sometimes, after doing all of that, you still have to interpolate. It's a huge pain, I don't like it either. What I'm going to talk about today is an alternative way of looking up this information online that in many cases will prove to be much easier and hopefully a time saver. Imagine that we're tasked with determining the specific volume of refrigerant 134A vapor at 13 degrees Celsius and 1.4 bar. What we're going to do is to use this website. It's the National Institute of Standards and Technology, an organization that is probably most famous for refining and maintaining definitions of the kilogram, meter, etc., but in my opinion is most useful for maintaining an online database of material properties. What I'm going to do here is just to show you a recording of my screen when I go to this website to determine the properties of refrigerant 134A. I encourage you to potentially visit this website at the same time while you're watching this video just to walk through the procedure and make sure you're comfortable with retrieving data this way. So over here, I'll show you what my computer sees, and let's just make this full screen so that you can more easily follow along. So to start, this is the website up here. These are all the potential things that you can look up, and our first task is to select the material, so we'll pick R134A. You can see they have a gigantic list, so you have to read carefully. And over on the right, it's R134A in parentheses, so that's it. So I select that. I want to work in Celsius and bar because those are the values we're given. We'll select kilograms per cubic meter for density. The other stuff isn't going to be relevant for this particular lookup. Now you have the option of selecting isothermal or isobaric properties. We're going to go with isobaric, which means that we're going to go through, fix the pressure, and then look at a range of temperatures. These defaults are fine. We'll press this to continue. So now I get to enter the specified pressure that we were supposed to look up. So it's 1.4 bar. And I'm going to do a temperature range from 10 to 20 degrees C, and we'll go in an increment of 1 degree C. Over here, you can increase the precision with which these values are reported. Always move that up. You can never have too much precision. So now let's look at this, and they present the information graphically at first. Now this is the density, not the specific volume. So we can select the specific volume. You can see from its units that specific volume, cubic meters per kilogram, and already we have the answer, 0.16099, etc. cubic meters per kilogram for the state that we specified. Great, we're already done. It's always good to make sure that we're looking at R134A and that you didn't accidentally select water or something. Now, there are other values listed down here for various other quantities, and you can imagine needing those. You can also look at this stuff in an HTML table. So if you want it organized in a different fashion rather than graphically, you can see this table, and here for our temperature, here's this corresponding specific volume, and then there are all these other quantities to the right that you could look at. You can also download the data. As we'll see, this is tremendously useful if you need to look at this data in a spreadsheet program. So for instance, if you right-click and click Save As, then you can specify the file name and save it to your own computer for potentially analyzing it later in some spreadsheet. Now, after doing all of that, we've seen that we've exhausted all of this information for R134A. That was the isobaric case where we specified the pressure. I just want to show you what happens if you select isothermal. So everything else is the same, it's still the same material. We made all the same choices except we switched to isothermal properties, and now you get to specify the temperature. So I type in 13, we're still in degrees C, always good to check that. I'll type in a pressure range. It's going to be narrow. I'll go from 1.3 to 1.5 bar with an increment of 0.1 bar. And again, we'll increase the precision. And now looking down here, we can switch our graph to the specific volume again. This had better be the same answer, and it is. It's 0.16099, etc. Still the same substance. Great, we did a good job. And again, you could go through and view this in an HTML table. The table is not exciting. I only had 3 different pressures, but you can see we got exactly the same answer. And of course, you could go through and download the data again. So these are 2 alternative methods of looking up the same sort of data for R134A. In my opinion, though, if you were faced with an interpolation using the appendices in the back of your book compared to this is way faster.